Hello, welcome to the tutorial on performing a service demand sensitivity. So there are a couple of ways to perform a service demand sensitivity, but there's one sort of preferred way, and so we're really going to focus on that. The two ways are, number one, you can actually edit the service demand data directly. So if you just want to change, for example, a vehicle mile traveled projection, you can do that. To perform these sensitivities, it's sometimes better to maintain the underlying base data and alter that trajectory with a measure, and so that's how we will be. That's what we will be walking through today, because that really is the preferred method. So we're going to start here in service demand measures, and I've actually pre-loaded some of this data so that we can move quickly through it, but I've added a measure called VMT test measure. That is in subsector 72, which is our light duty auto subsector. There are two potential input types. One is total, and number two is intensity. What that means in the context of a service demand measure is if you input it as a total, you need to add a unit so that it can alter the service demand in terms of the total input. And what that means is, we have service demand projections for our light duty autos in terms of VMTs. So if you were entering a total service demand measure, that would be entering something like 100 million VMTs, and that would change the trajectory by 100 million. An intensity would be saying change the service demand projection by 10%. So that's the difference between total and intensity. If you do intensity, which I'm doing here, you don't need a unit because it's in terms of that service demand unit. For geography, in this case, I want to alter the whole US, so I'm just going to do 4. There are no other indexes to our service demand data. Even if there were, we could do a intensity as a function of the total, and it would alter the underlying service demands no matter the underlying indexes. But in this case, we don't actually have any other indexes, so we're going to leave those blank. We're going to use our standard interpolation method of 1, which is a linear interpolation, and the extrapolation method is 4, which is nearest. The other thing that we need to input is actually the projected life of the measure. So sometimes these service demand measures really aren't equipment and they're behavioral, and so these inputs maybe don't make as much sense, but sometimes they actually are physical interventions. So for example, lighting controls would have a projected life. And we use that to basically create a stock representation of these measures, and that's used to accurately account for costs of the measures. So in this case, I'm going to say these VMT measures are sort of widget based, and so we're going to imagine that they have a lifetime, and so they have a decay function. We're going to say number 1, which is Yval, and we're going to say these measures last 25 years. So if you perform an intervention to reduce service demand, it's a 25-year lifetime of that measure. So min lifetime 25, max lifetime 25. Next up, we're actually going to want to edit the projection of that measure's impact. And it's important to note here that service demand measures are assumed to be reductions in service demand. So if you input, as you see here, for our measure 16, an input of 10% reduction of 10% in 2050, so positive 0.1, that represents to the model that you want a 10% reduction in VMT projections. So it's important to understand that concept so that you're not putting negatives and reversing the impact that you actually want to see. So in this case, as I said, we are going from no impact today to a 10% impact in 2050, so that would be reducing VMTs on the order of 150 billion vehicle miles traveled or something like that. So that's the impact that we actually want to measure using this service demand measure. Next up, I'm going to go to cost. So in this case, we're going to assume, again, it's a widget-based intervention that comes with a cost. So it has a currency ID. Number 41 is US dollars, but if we were given these costs in euros, we could input them like that, or any of the 41 currencies that we have loaded up. Currency year, we're going to say 2014. Cost denominator unit is mile. So what this will do is say, okay, if your cost is 10 cents per mile and you save 150 billion miles, then your cost is going to be $15 billion. So that's what that denominator unit is doing. Cost of capital, we actually need to turn those capital costs, if they are levelized, into an installed cost, and so we need a cost of capital to do that, and so we can input that here. The question is if it's levelized, so that 10 cents a mile that I've been using is actually a levelized figure. So what that means is it's going to assess 10 cents every year, every mile you reduce. So we're going to say true here, it is levelized. Those costs are the same across the US, so we're going to use geography ID 4. And our standard interpolation method of 1, extrapolation method of 4. Then we need to actually enter the cost data, and in this case I'm going to say there's only one cost, it's 10 cents a mile. It's for vintage 2015 and any other vintage that you input. So we now have a measure defined. It has the impact and it has the cost. Second, we need to load that measure into a package. Packages to measures are one to many. In this case it's just one to one, but the structure is one to many. So we input what I'm calling here a VMT sensitivity test package. Then we go to the data, we input the package, which is 15, we load the measure into it, which is 16, and we're good to go. So we've now defined the measure, we've loaded the measure into the package, and now what we have to do is actually put the package into what we call a demand state. Demand state is a combination of packages operating in concert on a subsector. So as you can see, we have the option of a stock package, a service demand package, an energy efficiency package, a fuel switching package, a sales package, and a flexible load package. So what we are going to do here is only use the service demand package for this. And so what this means is the package that's operating is a baseline projection of light duty autos, except we are altering the trajectory of the VMTs using this package, number 15. The description I'm using is LDA VMT test state. So now that we have a state, we actually have to load that into a case. This all seems like a lot of work when you only have one measure, but when you end up with aggregates of measures and aggregates of packages, the structure tends to save a lot of time. So we now go to demand cases. I've added a demand case. I'm calling it the VMT test case. And then the data is, again, one to many. So a case can have multiple states. And so case ID 17 is our VMT test case, and I'm adding the state that we just added to our case. So we now officially have a case to run. So we would basically just run this case, and we would run a case without any states at all. You know, if we wanted to do demand case 18, would just be a baseline with no states operating at all, we would just add demand case 18 and just not add anything to this table. We could run them separately, and then the net impact of that would tell us the value of that measure in terms of costs or emissions, etc. So that is the best way to perform a service demand sensitivity. Thank you.